In section 6.6, where we were learning how to calculate surface area, it leads us to an integration formula that usually has a pretty nasty looking function that we don't necessarily know how to integrate yet by hand. So this is one of the instances of why exactly we require a graphing calculator for this class. You most likely have not learned any techniques yet that will allow you to calculate that on your own. So this is one that's definitely a good candidate for just typing it into the calculator and letting calculator do the rest of the work for you. Because really the objective of this whole chapter is just to learn new things that integrals can help us calculate and learn all the different setups of our integral for those calculations. It's not so much focused on do you then know how to calculate that integral. That's actually what chapter 7 is going to be about. So I'm sorry this video is got the wrong orientation, but I think it's going to help better with looking at the calculator. So in one of the examples, when we got to the point where we had our integral set up, we had integrate from 0 to pi over 2, the function 2 pi x times the square root of 1 plus 4 cosine squared x with respect to x. And this can be kind of tricky to type into your calculator. One is because the normal math notation we use when a trig function is squared, we write it between the function and the x, but really what it means is that that entire cosine function, that entire cosine value is being squared. So really, I guess this notation probably just came about to avoid having to write those extra parentheses. So I tried to write this out a little bit more like how we're going to put it into the calculator. Before we actually put the integration in the calculator, another really important step you might miss that would make you get this wrong is because we're going to be evaluating a trig function, these limits are radians. So you need to make sure that your calculator is in radian mode. And the way that we do that is we go to mode, and the fourth list of options are going to say radian or degree, and we need them to be in radian. So just arrow down until radian is flashing and then hit enter. And it changes it to radian mode. So now I can go back to my home screen and I'm going to try to type in my integral. So a lot of times in calculus, the teachers will show you how to do definite integrals in your calculator, but mostly it's from the graph just to show the link between area under a curve and integration. But you can also integrate directly from your home screen by going to Math, option number 9, and that will pull up a definite integral onto my screen, and it's got blanks for my limits of integration, a blank for the integrand, and then also for the variable at the end. So we're integrating this one from 0 to pi over 2. And what we are integrating, well, when I type these integrals that have pi in them, it seems like the last few chapters or the last few sections, they've all had a pi. MyLabs Plus usually wants an exact answer, so we can't put that pi in, or the calculator will try to change it to a decimal. So I just leave the 2 pi until the end and then include it in my final answer. So I'm just going to put, starting with x in here. So I've got x times the square root of, so the square root on many calculators will open a parenthesis. Mine does not, just because it's one of the newer ones. But the 1 and the 4 are not inside any sort of parentheses besides the one that indicates the square root. So I can go ahead and type in 1 plus 4. And it's the cosine, only the cosine piece that we want squared. So now I'm going to use some parentheses to enclose the cosine function. And it's cosine. Now look, as soon as you hit the cosine function, it opens another set of parentheses. So the first time I close them, all it does is close the parentheses on the angle. And then the second time I close them, it encloses the entire cosine function. And now I can square. And then I'm going to tell it we're integrating with respect to x. And this one does not come out to be a nice rational number. If it did, it would either be a terminating decimal or it would be a repeating decimal. And those you can go to Math option 1 and change it into a fraction. If you try this and it doesn't change, then it's probably just an irrational number and you're not going to be able to do an exact answer. But don't forget, we also need to multiply in our 2 pi. So I'm going to take that answer and say times 2 pi. So I got about 11.0947, 11.1-ish.